Welcome to Mr. Brown's Basement, a channel devoted to sharing the craft of repairing, restoring, and modifying vintage electronic gear, and other random stuff.
Let's take out the chassis. It looks like it's held from below by screws, and this is probably asbestos. We're not going to keep that. In fact, I'm going to do that outside. 3 screws held on the bottom, and here's the inside underneath. Lots of capacitors that need to go. There's the main filter cap. All these papers have to go, and no, I won't be restuffing them. Now there are asbestos fibers here. I'll have to take them off with something wet so that they're all captured. That is going to go. I'll keep the wood, but that asbestos sheet is going to go into a bag and out with toxic waste. Actually, they've stapled it on. Isn't that nice? I'll wear a mask for that. Now that all the fluff is gone, it's easy to take a closer look at what we're dealing with. So the filter cap, 1, 2, 3, 4, 5, 6, 7 paper caps that I can see, probably more hiding underneath. That's looks like a coil right there, but I can't tell for sure. This is a paper cap for sure, even though it doesn't look like it. This may be a replacement, and I really don't know what this is about. No, that is not factory. Looks like somebody was trying to solder something with a soldering iron that wasn't hot enough. The dial string is broken, and the antenna is also broken. Here's the chassis from the front. All right. This plastic here has been burned. It's fairly typical in radios like this. It just gets too hot and the plastic begins to discolor a lot. Here we can take a look at the dial. You can see the paint has come right off. Moisture, heat, or both. Curiosity got the best of me, and I decided to take out the screws that hold the record player down. The washers are disintegrating, so they will need to be replaced. And that's the remains of lubricant. So this will have to be cleaned up. Okay, I haven't done this yet. This is the first time I've ever seen underneath this unit before. And it's captive somewhere. I can't see. Oh, it's on the door. Okay. I'll release it from there. There we have it. Not much underneath here. This is the part that connects to the door. Okay, I see what's going on. This is a mercury switch. Something you don't want to break, which is a good reason for wrapping it in paper. I thought I read somewhere that these things unplugged from one another. The chassis could be easily disconnected from the record player, but they're soldered on this terminal strip. I don't want to work on both of them at the same time. I'm going to unsolder these here. This looks like the audio from the cartridge, and there's ground right there. And this is probably power to the motor. In fact, it can't be anything else but power to the motor. So let me desolder it, and then we can look at just the chassis, and then I can look at just the record player. The chassis has now been disconnected from the record player, and I can now start working on this. Now some people might say, well Brown, why don't you just plug it in and see if you get the magic smoke? I'm not going to do that. I don't see what there is to be gained by doing that. As I remove the tubes, I make note of what tube belongs in that socket, and I've got as far as the 50x6. You can see that it's run quite toasty. The socket is not in good shape, but it's something to keep in mind because possibly I'll have to replace the socket. Whatever this material is, it's been baked. That doesn't make it Bakelite. These tubes are known as Loctol, which were Philco's answer to the industry standard Octal, which came out, I think, in 1935 or 1936. These pins did tend to get badly oxidized and made poor contact. I think I have replacements for all of these except perhaps 50X6.
They're rare compared to
50L6, which is the audio amp,
that are still quite common. These three, 7A8, 7B7, 7C6, are quite common, but they're becoming more expensive.
The first tube I'm testing is the 7C6, only because it was handy. I set the tester appropriately. When I hit test, it goes down to 0. That's highly unlikely to be a bad tube. It's most likely to be a bad contact on the tube. And the filament isn't lighting. Wiggle it around a bit, and let's see if we're getting anything. No. Well, I've cleaned the contacts and I'm still not getting anything. I find it very hard to imagine that this tube has an open filament, so I'm going to connect it up to an ohmmeter and see if the filament is open or not. So let me turn it to continuity. Okay, the filament is fine. Well, after cleaning the pins within an inch of their lives, guess what? It's not very good. I'm testing the 50X6 rectifier. It's got two sections. One section is just so-so, and the other section is so-so. Is it so-so enough to work? Probably. But at the end of the day, what matters is how well it works in the set, not how well it works on the tester. This is the 50L6. Nice glow there. Is there nice emissions, though? No. As I try to make heads or tails of these schematics, I realized that for this radio, there were at least 6 different versions of the chassis, and they used a variety of output tubes and rectifiers. My chassis isn't like any of them.
My chassis is a 706, which is a Canadian model.
There is one schematic that I've been able to find for this chassis, but I suspect there's more than one version. And that's because there's some stuff in here that looks like it's factory, but it's not on the diagram. It's time to start recapping and testing resistors as I go. But there are a couple problems. First of all, some of the values are not easily acquired, like 25 microfarads and 40 microfarads, this one here. But that's okay because, regardless of what some people say, it's not that critical. For a 25 microfarad capacitor, I can put in a 33. And one of the reasons is that with electrolytics, the tolerances are huge. So this may have been even more than 33 when it was new. Doesn't matter. As long as you don't go really crazy, it will work just fine. The other issue is that most capacitors of this era are axial like this. But today, to save space, most capacitors are radial like this. And they don't span the distance. For example, this capacitor here is going to have to go from this spot here all the way to in there somewhere. And it can't possibly reach if it's radial. In fact, even if it's an axial, it would be pushing. So what I'll probably do is put in a terminal strip over here somewhere and mount everything I can there. Besides, I've got some space here. Why don't I just use it? Today's capacitors are so much smaller. Why don't I make use of the space that I free up? As a rule, don't worry that much about the exact values when replacing capacitors. And if you're forced to use radials because you can't get axials, you can always use a terminal strip. Something I have been doing lately is adding spaghetti. Now, some people would say, how dare you do that? But I do that so that I can see where I've been and see what's been replaced. And presumably, future people can see it too. When I remove a capacitor, I don't just remove the capacitor, I also remove the wire that it attaches with. So I'm going to heat up this lug and unwind this wire so there's more room on the lug for the next wire. The same thing on a tube socket. There's no point loading it up, so you end up with a monstrosity that looks something like, where is it? Like that. That's ridiculous. This resistor here, it's supposed to be 47K. This one is the replacement. The original had wandered up to about 64 or 65K. That's no good. I test the resistors as I go. Carbon composition resistors have a tendency to drift, usually higher, and if they're way out of tolerance, the radio won't work properly. This is an unusual part. It's labeled 389957-1. It is a capacitor with a coil around the capacitor. Philco called it a resonant capacitor. What I'm going to do is heat it up and melt out the capacitor and then put the new capacitor in the same place. With the aid of a heat gun, I got the capacitor out. Now, according to the schematic, it was 0.2 microfarads. But instead, I found this, 0.006 microfarads. And it's rated for 115 volts AC. It almost sounds like a line capacitor, which it can't be. Certainly not wired in the circuit that way. I will replace with another 0.006, not with a 0.2. Recapping is done, but I'm not certain if it's going to work without the antenna coil connected to it. But I'm going to try, at least insofar as making sure it doesn't smoke. This big resistor here, which was totally unnecessary, was replaced by this resistor here. I've added a fuse on the line side in series with a switch, just in case, 1 amp fast blow. And I got the speaker. There are a few minor tears in it. They're relatively inconsequential. As usual, I will test it through the variac so that if something goes wrong, I can turn it off in a hurry, and I can also ease up the voltage and stop it if something goes horribly wrong. Here goes. It's off, down at 0 volts. And I'm going to turn it on. Turn up the volume. I don't know whether that's all the way on phono or all the way on radio. But is anything happening? Tubes are lighting up. We're at about 50 volts. I said I'm using the original tubes, and some of them are quite weak. I've got it almost at 100 volts, and B plus is gradually increasing to about 55, 56 volts, when it should be actually closer to 120, or certainly 100. So I'm going to replace out the rectifier, which I already know is weak, and try again. I'm getting nothing, not even hum through the speaker. I put in a different rectifier, and guess what? It's weak too, but it seems to be less weak than the one I just took out. Did I mention the output tube is weak as well? Maybe I should replace that. I'm going to nudge it up closer to 100 volts. 110 volts. Almost there. Got 100 volts in. Pretty darn close to 120 out. But I'm not getting any sound at all. Well, maybe it's the very weak output tube too. I'm going to look for another 50L6. I have it on what I believe is the phono input, and when I touch the phono input I should hear hum. What I get is a voltage drop, which suggests to me that it's humming, except I can't hear it. Maybe the speaker is bad. Maybe the output transformer is bad. I think I may have found the problem. This may not have been in, or it may have popped out.
There are 5 wires on this receptacle, a red, a green, a black, and 2 whites. You'd expect that they would line up with the leads on the speaker. Green going to green, red going to red, white going to white. No.
The black lead
Connects to the plug, but then it doesn't connect to anything else. You will have to trace the field coil wires and the output transformer wires. You cannot rely on the color of the insulation they used.
I've had it with this connector. It's very stiff, it's unreliable, and it's going to be replaced with an automotive connector which certainly can handle the voltage and the current. Here's the speaker end with the new connector. I think it'll be easier to manipulate while I'm working on it. And the other end, and the black one is just terminated because it doesn't go anywhere. I've got 60 Hertz hum. That's a starting point. At least the amplifier is doing something, but it doesn't seem to have any sensitivity at the middle of the volume control.
Which means there's something wrong between the volume control and the output tube.
But at least it's something. This is the grid of the output tube. So the output stage is working. 50L6 is fed by the 7C6, so I need to find the input of the 7C6. The 7C6 was weak on one section. I'm going to replace it with a different 7C6. This is the original. Replacing that 7C6 has changed things. First of all, the volume control now does something. Second, if I touch the phono input, there's plenty of sensitivity. So let's try the radio side. Now on radio, I've got background noise. And it seems to be trying to pick up stations, but not anything really. But remember, it doesn't have the built-in antenna hooked up yet, so those terminals are open. This is the antenna coil that I took off the case. Not in very good shape, but it does measure a few ohms, which is as it should. I've sanded, you can't really see, but I've sanded the ends so we can actually connect it up to the radio. Connects up to the input of the 7A8. Without that, it doesn't look like there's any tuning in the first stage, so this needs to be in the circuit. Yeah, it works.
Happy, happy, joy, joy, happy, happy, joy, joy, happy, happy, joy, joy, happy, happy, joy.
But I'm sure it needs an alignment that likes to squeal, and it probably needs a tube shield as well. But yeah, as I said, it squeals, but it seems to work. The next stage is to patch the speaker. That's done with paper towel. I'll get to that. Replacing this pilot lamp. I'm not going to use incandescent. I'll get an LED equivalent, and that will work nicely. The dial cord. It's actually 2 dial cords. One that moves the tuner, and you can see that it's moving, but the other one that moves the needle across the dial, and that has to be restrung. Still coming up is the record player and the cabinet. There's plenty of work ahead on this project.
And I hope you'll join me for it. I hope you enjoyed this video from Mr. Brown's Basement, and please like and subscribe to be notified when new videos come out. Thanks for watching.